Hi, and good afternoon. Thank you for coming to listen to this. My basic question is, have you ever wanted to fly? I'm not talking about riding in the back of a jet. I'm talking about getting out in the wind and flying the way we dreamed of when we were kids. What are the pain points of general aviation and personal flight? High cost, complex operations might top the list. Plus, you have to drive to the airport, and you can only fly to another airport. When young people come out to the airport nowadays and look at general aviation airplanes, I'm not sure if they're seeing the future. They're seeing a lot of aircraft that look old and tired because they are pretty old. There are ways to experience flight on a very personal basis, but most of them involve jumping out of airplanes or jumping off of cliffs. And so for most of us, this is pretty darn scary, and it's a pretty short experience each time too. Hi, I'm Jim Corning. I've got an engineering degree from MIT, a $3 million a year company where we build components for aircraft. And we're just developing the FanFlyer Inc, which is a very new personal flying machine that'll fit in a parking space. It'll levitate straight up. You can fly for as short or as long as you want to. You can fly as slow or as fast as you want to, up to about 80 miles an hour. You can stay down low and see what's going on the ground, or you can climb up to 10,000 feet. We're designing for a 10,000 foot service ceiling so that people here in the mountains can fly too. So why is this possible now and not 20 or 30 years ago? We've actually based this design on aerodynamic data from ducted fan aircraft dating back to the 50s and 60s. What's new is that flight controls from drones and UAVs are making it possible to add stability so that these machines will be safe and easy and fun to fly. And developments in high-performance electric drives make it possible to add redundancy to the powertrain so that even if any single powertrain component fails, you have a way of flying to a safe and controlled landing under power. So what's the market for these machines? There's 600,000 licensed pilots in the United States. There's 175,000 members of the Experimental Aircraft Association. This is an organization of people who build their own airplanes, often from kits. There are 30,000 kit planes that are registered with the FAA nowadays. And when you look at the last 30 years of production of Cessna, Piper, Beech, and Mooney, home builders have been building and registering more airplanes than the mainline manufacturers. In addition to recreational uses, there's police departments and search and rescue organizations that could use these tiny machines to great benefit. There are, there are 10,000 wildland firefighters and 300 smoke jumpers working every summer. And wouldn't it be awesome if we could give these guys a way to get to the backside of a fire and get back in one shot? We have 30,000 special forces operators, many of whom parachute into unfriendly territory, carry out their missions, and then have to call for a helicopter to come and retrieve them. Imagine the flexibility that we could give these guys if they could fly their own missions, put these machines under a camo net, carry out the mission, and then fly back. And they could fly off in 10 different directions, for that matter, which would make them really hard to track. There are 8 million motorcyclists in this country. So why am I talking about motorcyclists? There are a lot of parallels between motorcycling and flying, the banking through turns, being out in the wind at speed. Most of the motorcyclists that I know are fascinated with this project, and I think they're kind of a leading indication that the market will be much larger than the existing typical general aviation market. So who are the competitors? There are several companies that have built jetpacks, and they're able to fly for perhaps 10 minutes at a time. They consume fuel at a ferocious rate, which really limits their capability. They're talking about selling copies for $150,000 to $400,000. And then at the other extreme, there are electric ultralights, which are also very limited in flight time because they're using lithium batteries and they're using the best that we can get, but battery development still has a way to go. 10 to 20 minute flight times, none of them have announced pricing yet. To my knowledge, none of these have actually sold a product yet. We're aiming for a sweet spot in between these two extremes. With a gasoline engine, hybrid electric drive, and 4 ducted fans, we're going to have a more efficient machine in some respects. And the intent is to be able to fly for an hour or more, to cruise at 80 miles an hour, and to really have something that you could actually fly somewhere and do something with. Our business model is to own the design, systems integration, and manufacturing pieces for this. And we have a kind of a three-phase program for going to market. Phase one is selling kits to the aircraft home building community. The biggest seller of kits in this space is Vans Aircraft in Oregon. They deliver 250 kits at $50,000 a year. It'd be pretty easy for us to match that with a somewhat simpler and unique vehicle and get to $10 million a year in sales. The beauty of this is that FAA certification is not required to sell kits to home builders. The home builders are responsible for building 51% of the machine, and they're responsible for the airworthiness aspects of it. So this gives a way to get to revenue much quicker than most aviation projects. Phase two is to develop a two-place FanFlyer with a turbine engine for the military operators. Going through a military certification process is not cheap and it's not simple. It's very rigorous, but the beauty of it is that when you get involved in a project like this with the military, they want to buy something, and so there's definitely a schedule and an end in sight. And then phase three is to get FAA certification of these machines. In many ways, that will parallel the military certification process as far as the airworthiness requirements. One of the challenges with the FAA, and I should say I worked for the FAA myself in aircraft certification in the 1980s, so I'm familiar with this territory. They don't have rules for these tiny aircraft yet. They're going to have to come up with special conditions and a combination of the Part 23 light airplane rules and helicopter rules that make sense to them. My Nova Kinetics Aerosystems company is providing an incubator for this operation so far. We have a 1/3 scale model that's flying. We've built some of the composite primary structure pieces and load tested them at 3.5 Gs. We've built a full-scale mock-up. The primary purpose will be to pull molds off of that for the composite, the carbon fiber parts that will be in the actual flight vehicle. But we found it fun to use for display purposes too. And we're very close to completing a ducted fan test rig, which will let us evaluate blade shapes and control strategies and pretty much all of the mechanical stuff that goes into making a single ducted fan work properly. Our schedule at this point is to have a machine that we can do first hovers in late summer, early fall. We just learned on Monday that we've been selected to be in the Innovation Showcase at the Experimental Aircraft Association Convention this year in July. That's a great opportunity to get out in front of the flying public, and I'm really excited about that. That's one of the biggest air shows in the country. We're hoping to do initial hover flights somewhere in between Oshkosh and the Reno Air Races, and to exhibit at the Reno Air Races as well. We're looking to sell some equity in the company in exchange for enough capital to get to phase one where we're selling kits. And so that is basically working through the first flights and the flight testing program, getting some good flight test data, participating in the Go Fly Prize competition, which will be in the first quarter of next year. We naturally would like to win that. And then to develop a two-place FanFlyer kit. A two-place machine is a high priority because it'll allow us to introduce people to this flight experience safely, and we can use it for flight training. Thirdly, it will be something that can actually carry a payload and where we can demonstrate search and rescue kinds of capabilities. So we've invested $160,000 in this ourselves so far. I mentioned that we'll continue to squeeze as much as we can out of my operating companies. We're looking for an additional $600,000 to work our way through about 18 months of what I've just described and get to where we can start having some kind of positive revenue. Additionally, we're looking for engineering and controls talent and some project management leaders. Any questions?
Thank you.